Thank you so much for joining us. So we continue with our topic. So remember, we are still on travel time graphs. Okay. Now the first and the last class that we had, we introduced this topic in the first class, and in the second one we looked at some questions on how to solve questions involving distance. That was distance time graph and speed time graph. Then I gave you this one to try, this question. Yeah, some of you tried, and especially the first question, that is A, calculating the acceleration. It was most of you answered it correctly, but the second one and the third one, you are making some mistakes, and that's what I want to clear today. Okay, so I really request for your attention. So the question says, the diagram below shows a speed time graph of an object. Now this object started from rest and accelerates uniformly for 4 seconds until it reaches a speed of 20 meters per second. This is what you can see here in the diagram. Okay, that is in the graph, I mean. And then moves at this constant speed for further 8 seconds and then accelerates until it reaches a speed of v meter per second. Okay, that's what you can see. That is in after 7 seconds, and finally it retards for the next 10 seconds. Okay, so there it comes again to its resting point. Okay, so remember time we add. So here the first was 4 plus the second was 8, giving us 12 time here, and the third time it took was 7, giving us 19. The last one was 10, adding to 19 we got 29. Okay, all right, so now let's go into calculations. So the question A is calculate. Let me just scroll down. So it's saying calculate A, the acceleration during the first 4 seconds. So remember, we use the formula. So again, we go by the formula, that is v minus u, okay, over t. So t, that's the time it took. So the change here, our final velocity, remember the car started from rest. Okay, when something is resting, there is no speed to it, isn't it? So there is no speed to it. That means our initial velocity is 0. An object was resting. Okay, now from resting, an object, that is a car, reached a speed of 20 meters per second. So in the first 4 seconds, our final velocity is 20 meters per second. Okay, minus initial, which is 0. That is when the car was not moving. Now this speed changed within 4 seconds. Okay, so there 20 minus 0, it will still give us 20, and then 20 divided by 4, you got 5. Okay, 5 meters per second. Now remember, this is what? Acceleration. So since this is acceleration, its units is meters per second squared. Okay, so we've answered the first one, and most of you got this one correct. And now let's go to the second one, that is our B. Okay, so our B, the question is we are being asked to calculate the value of V. Okay, so before you calculate the value of V, before you do anything, try to analyze what is happening at V, that is in the last 10 seconds. So in the last 10 seconds, we are considering this triangle. Okay, this one here, the last triangle. Now in the last triangle, the car is already moving at v meters per second. This is the speed, okay, at which it is traveling. So while it is at v meters per second, it starts reducing its speed until it reaches the resting point. Okay, so this becomes our initial, because that is where the the car is starting to retard. Okay, so this is our u, and then this is our v, our final. Okay, so our u there, our initial will be v meters per second. So it means we are calculating for u, for initial, because initial is what we don't know here at v. So when we calculate for initial, it means we are calculating for v, which is there, the one we are looking for. Hope you get that one clear. Okay, in the actual sense, we are calculating for initial velocity when the car started retarding, when it is already traveling at a speed of v meters per second. So v meters per second, which is the initial speed in this case, then our final will be the resting point when it stops moving there. Okay, the speed continue reducing from v meters per second up to when it stops moving, and that will be our final. Okay, so we apply the same formula for acceleration. Now see how the way we've analyzed it, and see how we are going to replace the values. So we have v minus u over time, isn't it? Okay, so let me just write here at the bottom. Acceleration, the question is the value of v if the retardation in the last 10 seconds is 3 meters per second squared. Now, like I explained in the first class, retardation is simply the opposite of acceleration. Okay, retardation is the value of acceleration but a negative value. Okay, so a negative value of acceleration gives us retardation. Okay, so this 3 meters per second squared is acceleration, okay, when it carries a negative sign. Okay, so this is acceleration but in the opposite direction. So where there is a acceleration, we replace it with negative 3, and then our final velocity is 0 from our analysis. Okay, then our initial velocity is what we are calculating for when the car was moving at v meters per second. Now t is the time it took for the car to retard. So the car retarded from 19 to 29. So what do we do to find the value of t? We've been given actually to say in the 10 seconds. But if you want to confirm, you can still subtract. You can subtract 29 minus 19. That will give you 10, isn't it? So you have 29 minus 19, and that will give you what? 10 seconds. Okay, so this is your time. So we put 10 there. Okay, yes. So again, this we can now what do you do here? You cross multiply. Oh, before we cross multiply, let's do this. Let's do this. So here you can, just for the sake of everyone to be at the same pace, here we have 0 minus negative u. You have negative u, right, over 10. Now you can cross multiply. So there, what are you going to get? So when you cross multiply, you're going to get negative 3 times 10. You're having negative 30 is equal to negative u times 1. You have negative u. Okay, now what do? You divide both sides with negative 1. Okay, we don't divide with a negative but a negative 1. Okay, so there negative 1, you divide with negative 1 to give you a positive, and there you divide with negative, that will be positive, and finally your u will be what? 30 meters. Okay, 30 meters per second, isn't it? So this is our u. Okay, now remember, this u we've calculated for you because it was our initial velocity when the car was already traveling at v meters per second squared. So in the formula, this was our initial velocity, which is u. So since we have calculated for this u, we know what this means on our graph. So this u is what is supposed to be here at the value of v, where we have v here. Okay, so the value of v that we've calculated is same as this value of u here. So we are just going to write it here for you to see, because we've already calculated it. So you can put it there for you to see that you have the value of v, right? Okay, let's go to the last one. What is the question asking us to find? So the last question is the average speed for the whole journey. Okay, so this one, most of you made mistakes because you didn't know what to do. You were you didn't have the distance, but most of you were just calculating the distance in the first triangle, and then you divide by the time, which is 29. So those are the mistakes that you are making. Yeah. Now here is the right thing to do, and why. We are talking about the average speed for the whole journey. So when they talk of for the whole journey, it means you need to find the total distance for the whole journey. Okay, the total distance for the whole journey, then divide by the total time taken for the whole journey. So in the first class, I used different formulas. I took this one as a trapezium. Okay, but this time I want us to use an alternative. You just have to consider this one as a rectangle. Okay, this one here, and calculate it alone, that is on its own, because some of you may have issues to calculate using a trapezium, but it's the easiest way. It's the easiest way for me. Okay, so let's use that one and see what we are going to get. So the first distance we have is the triangle. Okay, is the triangle. So remember, to calculate the distance, we use the area under the what? The graph gives us the distance. Okay, so we can use d. If you did not watch the first class, please make sure you watch the video so that you can catch up. So it's BH. Okay, that is the formula for the area, which we use as the distance, which is the area under the graph. So we have the BH. Okay, B, that is the base times height. So we have half there. Okay, but what is our base? So our base is 4. That is the first triangle. Our base is 4. Then multiply by our height is 20, isn't it? Okay, so when you divide there, you can divide 2 into 4. That will give you 2. And then 2 by 20, that will give you 40. Okay, that is 40 meters. So this is the distance in the first in your first triangle. So the second one, you have your rectangle. So you consider it as a rectangle. I didn't want us to consider a trapezium so that people can use different ways, whichever will be easy for them. So a rectangle, how do you calculate the area for the rectangle? It's L times B, isn't it? And in this case, what is our length? Our length is between 12 and 4. So we are going to subtract 12 minus 4. We'll get 8. Okay, so 8 by what is our breadth? It's 20, right? That's 20, and that will give us that is, if you multiply there your 8 by 20, what are you getting? You should get something like 160. Okay, you should get 160 meters. That is the distance you have there. Okay, then the other one, the third one, we have a trapezium. That is a trapezium. check it properly where it's passing. So this is a trapezium, this one here, going like that and then like that. Okay, this is a trapezium. So remember the formula for the trapezium, the distance, which is the area under the graph. So we have D is equal to half. Okay, so you have your half there. You have A plus B. You know how to get A plus B. I explained this in the first class. And this is your height. So replacing the values, you have your half there. Your A, you can get your A to be 8. Oh, sorry. Let's check on the diagram so that you see how I'm getting this. So our A can be from here up to there, which will be 20, or B. Then this one can be A or B also from 0 to 30. So one will be 20, the other one will be 30. Now look at the height that we have. The height is between 12 and 19. So 19 minus 12 there, you got 7. Okay, so we are going to have 20 there plus 30, okay, by 7 as your height. Now this will give you, here we can add, okay, let me use this color, 20 plus 30, you are going to get 50, isn't it? Yes, 50. Now you can divide in 2 into 50, you're going to get 25, isn't it? So you're going to get 25. So you have 25. You can confirm this. 25 by 7. Okay, and what are you getting? If you multiply 25 by 7, what are you getting? It's giving me 175 meters. Okay, 175 meters. I don't know, you can confirm. Then the last one is the triangle. Okay, the triangle is the last shape we have here. You can see it. So again, use the formula for the triangle. Sorry, what's this? For the triangle. Okay, so the formula for the triangle you have, so let's put this as our 4. Okay, hope you see now it is how we are calculating this. Our triangle there, so the formula, you know it, it's half, okay, by our base in the last triangle there. Our base is 10, that is 29 minus 19, you have 10. Our height is 30. Okay, so we are having, so half multiplied by 30 multiplied by 10, and you are getting, you can divide 2 into 30, you are going to have 15. Okay, so this 15 by 10, you are going to get 150, isn't it? So you are getting 150 meters. Okay, so the total distance for the whole journey, you have this total distance, you are just going to add everything you have. So you have 40 plus 160, what else? 40 plus 160, then plus 175, isn't it? Then plus 150, isn't it? So you get 525. So 525 is your total distance that the car covered. So to find the average speed, so you have your average speed, okay, is equal to distance divided by the total time, total distance divided by the total time. So this will be your total distance there. Okay, let me just show this. Your total distance there will be, you found it to be 525. Okay, confirm if this is correct. Divide by the total time, we have 29, and this is 29, sorry, okay, not 2q, it's 29, and you are getting, so there, if you, what you have, you divide it with by 29, you are getting 18.1034444, and the numbers continues. So we can just round it this, we can round this off to 18. That's a 0.1, it's just a 0.1 meters per second. It is the speed, isn't it? Okay, so thank you so much for watching. The second example is example 4. Let's answer it in the next video. Thank you.